Hello, this is the second part of the 2010 Oxford PAT. So we've moved on to the physics questions. We're starting off here with some multiple choice ones. Question 12, a rock sample contains two radioactive elements, A and B, with half-lives of 8,000 and 16,000 years respectively. If the relative proportion of A to B is initially 1 to 1, what's their relative proportion after 16,000 years? Right, okay, this is straightforward. A has had two half-lives, so A is down to a quarter. B has had one half-life, so it's down to a half. So we've got twice as much B as we have A. So that gives us answer B. Question 13. Two resistors R1 and R2 are connected in series with a potential difference V across them. What's the power dissipated by resistor R1? Right, so we've got this set up. Now, this total potential difference of V is going to be divided across these resistors in proportion to the resistance. So if we're looking here at R1, the fraction of the resistance that we've got is R1 over R1 plus R2. So if we multiply that by V, that's going to be our potential difference across R1. We need to square that and then divide by R1, because power is V squared over R. That's our, in inverted commas, formula that we're using. So we just need this, which is what? V squared R1, because the other R1 cancels with that one, over R1 plus R2 all squared, which is, oh, it's the first one. At least it saves us having to crawl our way through all of the four different options, trying to match up which one's which. Block of concrete, mass 100 kilograms, lies on a 2 meter long plank. So we've got 2 meter long plank. 100 kilograms, half a meter from one end. So that's going to be 1,000 newtons at half a meter when we got the full length of 2. If the builder lifts up the other end of the plank, how much force must he apply to lift the block? Right, so if we're going up there, we're just doing moments about the end. So we got 2x is equal to a half of 1,000. So x must be 250 newtons, which is C. A plane flies in a direction northwest according to the plane's internal compass. Okay, not entirely sure what that means. At an airspeed of 141 kilometers per hour, according to the plane's internal compass. So I suppose that's the, what it's been set at. It doesn't take into account it being blown around. Right, okay, that makes sense. Yeah, that would make sense. If the wind at the plane's cruise altitude is blowing with a speed of 100 kilometers per hour directly from the north, right, so this was 141 going that way. We've then got 100 going that way with an angle of 45 degrees between them. What is the plane's actual speed and direction relative to the ground? Right, well, since we're not allowed to use calculators, this is going to end up having to be easy angles. Because they've given us west, southwest, north, northwest, and south. Well, it's not going south, is it? We need to get the resultant. The resultant has to be going somewhere off to the west, and it's not going to be. Well, it's not going to be A, and it's not going to be D either. It's definitely going to end up being B, just because the others are ridiculous answers. So let's see. Oh, and we can see that it's going to be. Actually, that's a right angled triangle, isn't it? If you do 100, 100, and 141, because it's like doing 1, 1, and root 2. So it's definitely going to end up being B, because that would leave us with 100 going west. Otherwise, if you weren't going to do that, I mean, it just made me suspicious because we can't use calculators. You're going for cosine rule otherwise. So you'd be saying that our A squared would be 100 squared, so 10,000 plus B squared, which would be 20,000 because of the nice number they've given us, minus 2 times 100 times 141 times root 2 over 2. So that cancels with that. That will give us 200. So that would then cancel with that. And yeah, you end up getting A squared is 10,000, so A is 100. Yeah, so yeah, you kind of get forced into this because you're thinking, how on earth, if they had just asked for the speed, I might have been more inclined just to jump straight into cosine rule. But with direction and looking at the directions they've given here, then, yeah, well, it's got to be pretty simple. There needs to be something obviously geometric about it. And there was. That's why I picked the 141. Right, that was quite nice. I like that. 16. If a teacher wants to listen to a program on his favorite radio station broadcasting at a frequency of 1,000 kilohertz, but his radio only indicates the wavelength of the station. To what wavelength? Well, velocity is frequency times wavelength. So wavelength is going to be our speed of light divided by the frequency. So 3 times 10 to the 8 divided by, what did they say it was, 10 to the 6. So that's going to be 300 meters, which is A. Right, we don't mind those. Question 17, let's leave a bit of space as we got some. Two mirrors are set at right angles to each other. There you go. A beam of light which is perpendicular to the line of intersection of the two mirrors. Perpendicular to the line of intersection. All right, so it's not skewed. This is the line of intersection going in and out of the screen. So if it's perpendicular to that, it's just saying that the light coming in is in the plane of the screen, or the plane of the paper if you're doing this old school. The is incident on the first mirror at an angle A with respect to its normal. Right, so we've got something coming in at their angle A. Light is reflected by M1 and then by M2. So that would go out there and then it come out there. What is the angle through which the resultant beam is turned with respect to the incident direction beam? Right, okay. So if we've done A there, well, that's A, because that's how reflection works, that those angles must be the same. So that is 90 minus A, and so is that 90 minus A. These are 90 degrees minus A. So it comes in on a bearing of, so this is our way in. So our way in is on that bearing. So that's 180 degrees plus A on the way in. On the way out, it goes out at A. So we've got a change of 180 degrees. So exactly 180 degrees, which is B. Excellent. All right, question 18. A capacitor of capacitance 3 nanofarads is charged to a voltage of 10 volts. What is the charge held on the capacitor? Right, so capacitance is the charge per unit volt. So what we need the charge held. So the charge held is going to be, well, 10 times 3 times 10 to the minus 9, which is 3 times 10 to the minus 8, which is C. So that's just knowing if you know your capacitance definition. So, I mean, it grates a little with me that it's usually written out Q equals CV. I mean, it's getting away then from what capacitance is. Capacitance is charge stored per unit potential difference. So this is your first equation. It's C equals QV, and then you rearrange it. You don't butcher it by writing down Q equals CV. Anyway, question 19. The suspension spring of a car, which has got that spring constant, is sat on by a person weighing 80 kilograms. How much is the spring compressed? Right, so we're going, well, 1 meter needs 80,000 newtons. We've got 8,000, so we're going to go 100th of a meter. So we're going to go a centimeter. Well, they're giving them all in millimeters, so we're going to go B. We're going to go 10 millimeters. Yeah, we're just factoring these. We're doing 800 over 80,000 multiplied by 1. So bomb, 1 over 100. Question 20. A comet orbits a star at its closest approach to the star at a distance of 4 times 10 to the 10 kilometers. The comet has that speed. How fast is the comet traveling at its maximum distance from the star? Okay, so What's going to be the best way of doing this? We could either do this in terms of energy or in terms of Kepler's law. Might be quite nice, mightn't it? I think, yeah, let's go Kepler's law. So because I'm thinking of the one where you sweep out equal areas and equal time. So if you've got some radius r and you're moving with velocity v, so in 1 second you're getting this triangle of r times, well, r and v. This is what you're getting. Or you know, if you put r in the middle and we've moved v, you know, whatever way you want to look at it, we've got some triangle here with an r and a v, and that area has got to be the same. So these things are multiplied by each other. So if we've got, what have we done here? We've increased r by 2.5. So we're going to have to reduce v by the same amount. So we're going to have to drop down to 20 kilometers per second. So these things multiply out. So our 4 times 50 will be equal to 20 times 10. That's what we're looking at this. So we're going to end up having C. Yeah, you might be able to do something with energy on that as well, but it feels like it might end up being a bit fiddly. There's also quite a possibility there's another finding with all of this that I've forgotten about. But that came out fairly quickly, I think. Right, question 21. Fisherman sees a fish in a river at an apparent depth below the surface of the water of 3/4 of a meter. Given the refractive index of water is 1 1/3, is the true depth of the fish below the water's, well, below the surface? Oh, right, okay. Where is the fish actually then? Okay. Right, well, let's draw a picture because I don't really know where I'm going with this. This seems really quite difficult. So we're looking here. We've got some guy here. He's looking in the water. And so it's going to refract towards the normal. We've got our θ1 there, θ1, 2 there, θ2 there, and we've got a fish sitting here. But he's going to see this fish as if that had gone straight on. If it's gone straight on, so the apparent depth, this is our 3/4 of a meter, and we want to get the actual depth of the fish. Okay, so what can we say here? So sine, let's just do our Snell's law bit first. Sine θ1 over sine θ2 is going to be equal to 4 divided by 3. Just taking that to be, well, as 4 over 3 rather than writing 1.33. So if we've got that, we've also got something to do with, what else have we got something to do with? Maybe something with, well, we got tans in these things because we got the same. I'm going to change colour on this so I don't get mixed up. We've got this, so we're saying something about depths. We've got that D, so let's make that some kind of distance X that the fish is across. So we can say that tan of θ1, right, so that's this bit. So let's say something else about θ1 and θ2. Let's do tan θ2 first because that's easier. Right, so tan θ2 is our opposite over adjacent. So that's x over d. Tan of θ1, so θ1 is that angle there. So opposite is x. Adjacent is 3/4. So 4 over 3. Okay. Right, so maybe we divide these then, because that's going to get rid of x. So we divide, so we do tan θ1 divided by tan θ2. That's going to be equal to 4d over 3. How is this helping anything at all? Oh, well, we've got a sine. We can now put this sine θ1 in, because tan θ1 over tan θ2 is, what is this? This is sine over cos divided by sine over cos. So that would be sine θ1 over sine θ2 multiplied by cos theta 2 over cos theta 1. Okay, so we've got that. We know that sine theta 1 sine theta over sine theta 2 is 4 over 3. So that is 4 over 3 cos theta 2 over cos theta 1 equals 4 over 3d. So we can get rid of the 4 over 3s and say that is just equal to d. Right, how on earth does that help? Right, d, what can we say about, right, cos theta 1? Well, we know that cos theta, we know that theta 1 is greater than theta 2. Right, so that means that cos theta 1 has got to be less than cos theta 2, because as theta increases, cos is decreasing. So we know that cos theta 2 is greater than cos theta 1, so therefore d has to be greater than 1. Yes, yeah, I'm quite happy with that, I think. Yeah, that's come out nicely. The only time, I mean, if you're looking straight down, then that's the limit you're going to get. So yeah, it's got to be more than a meter. It's got to end up being d. That was a really difficult question. That's a written question. That's not a multiple choice question to wind these up for 1 mark. That's a 4 mark question. So it's making me wonder if there's something really obvious I've missed on that, because I've had to do a lot of work in order to get that answer, which does raise the possibility that maybe I've even got that wrong. It feels as though my steps are okay that I've gone through there. But it does make me think, have I just over-egged it in order to get 1 mark? Have I done it wrong? Or is there just a quick way that if I knew about the quick way, or I already know about it and I could remember it, then that would save a whole load of trouble? But I'm sticking with D. I reckon D's pretty good on that. That, I think, is the final. Yes, it is. That's the final one in the multiple choice question. So I'll be back for the written answers, although it feels as though I've already started them with this question. I'll be back in the next video with those.